Okay, good morning all. So today we'll go to the part A of this course. Okay, we are finished with the truss problem. Now what we'll do is in part A we'll take up the design of retaining walls, and we'll start with that one. How many are there? 19. Okay.
One hour. टच स्क्रीन है बहुत नीचे
Okay, let's begin. So this is what we'll be studying in our retaining wall. Okay, design. So this is one type of retaining structure that we are going to design over here. Other than this, we'll be designing one more type of retaining structure, which we call as the liquid retaining structure. This is a earth retaining structure. A retaining wall is a earth retaining structure, and the water tanks, they are liquid retaining structures. So these are the two types of retaining structures what will be there in your course. Okay. In case of earth retaining structure, what we have is the retaining wall are the examples of this. And these retaining wall, normally we use them for maintaining the surfaces of the ground at two different elevations. Okay, so it may be in case of roads, it may be in case of embankments for dams or any other structure. Okay, and in case of basements of the buildings. Okay, so we have parking provided in the basement, or maybe the basement is used for some other purpose. So what happens is normally this basement will be below the natural ground level. Okay, so in that case you need to protect the side of that earth which have been cut. Okay, so in such cases what we normally tend to do is we provide the retaining wall over there. So this is one way. Say this is a natural slope or in a hilly area normally where we come across. Okay, and what I want here is I want to have a road to be constructed on this hill. Okay, so this is how our road section will be over there. And what I want is I don't want this slope, this earth which is on the upper side, so it becomes unstable normally. Okay, so if you want to maintain the stability, if you don't want this portion of the earth to slide down. Okay, so here we have to construct a retaining structure over here. Okay, we have to provide a barrier which will hold this in position. Okay, all this earth in its position. Also on the downside of this road, you need a barrier which will prevent the sliding of this entire earth surface over here. Okay, so this portion will not be subjected to sliding. Okay, here it will be protecting the surface which is on the upper side of this slope. Okay, so this will not slide on your road. So these two surfaces what we have over here. Okay, so these are the retaining structures what we need to provide. Okay, so normally we call them as retaining walls, these two walls what we provide. Okay, so these are the retaining walls over here. So this is how we use the retaining wall normally. Okay, so that is the purpose of providing a retaining wall. And even what I told is in case of basements. So what you have is in case of the building structures. So when you construct a normally apartment or a high-rise structure or some building, so we go for excavation for footings. Okay, so this is if you are this is your normal building. So in case if you provide the basement, what I have to do is I need to provide it below the natural ground level. Okay, so I need to have this open space for maybe for parking purpose, or this maybe basement portion is used for some other purpose. So here I'll have to entirely maintain the earth or these sites in vertical positions. Okay, so in this case, what I'll be doing again here is I'll be providing retaining walls. These two vertical walls, what you see here, these are again the retaining wall. This one and this one. Okay, they are the retaining walls over here. So in this way, you will be able to have this basement provided, a open space which is provided maybe for parking purpose, any other purpose which you normally find in buildings over here. Okay, in case if basement is not provided, I don't require the retaining walls. Only for footing purpose, you need to excavate over here. Okay, and later it will be filled with the backfill. Okay, there we don't have such problem of or we don't we don't find any necessary of providing retaining walls in this normal building which stands above the ground level. Okay, only the foundation or footings are below the ground level. Here what I have is I have a basement area being utilized for some purpose. So there what I'll be doing is we will be going for this retaining walls which will help in maintaining this side ground at the higher elevation. Okay, so this is a higher elevation of the ground and this is a lower elevation of the ground. So two surfaces of the earth are maintained at different levels. Here also they have been maintained at different levels. This is one level. Again at the road you'll find this is another level. Okay, and here the normal ground level again. Okay, so here earth surfaces have been maintained at different levels with the help of these what retaining walls. Okay, that is how these retaining walls will help us in maintaining the ground surfaces at different levels. Okay, so that is the purpose of providing these retaining walls. Now let us come to the types in this case. So what we have is we come across different types of retaining walls. So this is one very old type of retaining wall which we used to have earlier, a masonry retaining wall. This is a stone masonry work which is constructed over here. So this serves as a retaining wall. You can see this sloping ground is maintained, okay, or this embankment maybe, okay, whatever you have. So it is maintained at a higher elevation compared to this level of the surface or the ground. Okay, so that is a masonry type of retaining wall. This is a stone masonry type of retaining wall, what you see in this particular picture over here. Okay, this is all, this wall itself is a retaining wall. There is a road over here at the lower portion of this retaining wall, whereas here there's the embankment or the natural, it may be natural embankment, it may be constructed embankment, whatever it is. Okay, but it is maintained at a higher level. Two surfaces have been maintained at two different elevations. Okay, so this is a reinforced concrete retaining wall. In this picture what you find here, this one is a reinforced concrete retaining wall over here. Okay, So what difference we have here is this is made with the stone masonry, whereas this is of concrete, and that too a reinforced concrete. Okay, so here again it is used for maintaining the earth surfaces at different levels. Okay, there will be a filling on this side. Okay, and there may be a construction of embankment over this. Okay, like that you will have to hold that embankment or the other side of the earth surface at a higher elevation compared to this ground. Okay, so this is what you find in a masonry type of retaining wall and a reinforced retaining wall, reinforced concrete retaining wall. Okay, and this is one more use of the retaining wall. Okay, maybe sometimes we may require such elevation difference have to be maintained on the ground surface. Okay, so there also we require to have the retaining wall, maybe masonry retaining wall, or it may be a reinforced concrete retaining wall. Nowadays we also come across precast panels, earth panels, which also act as a retaining wall. If you see the flyovers, okay, or the bridges, what we come across in our urban areas. Okay, if you observe the NH4 when it is passing through the Belgaum city, you find bridges constructed at Srinagar or at the Mandesh Nagar junction. Okay, so there you have reinforced earth panels being provided. We don't find any slope being maintained for that embankment. Okay, for the approach road, what you have is vertical walls, reinforced earth panels have been provided over there. So they also serve as a retaining structures. We call them as a reinforced earth panels. Okay, so there it saves space. Okay, that's why they have been adopted in those congested areas, like in our urban cities. Okay, they are also form of a retaining structures. Okay, this is another type. This type of construction, it will be done. This is actually a retaining wall here, but what I told, reinforced tarpaulin are slightly different than this. Okay, so this is a wall. What you find, this vertical side. Okay, so here, this vertical side is our retaining wall. Okay, these are supporting structures. We'll be studying about these types later. Okay, but this is all the retaining wall what you have. Okay, so on this side, later they will fill the earth here entirely. The earth will be filled, that is the soil will be filled, it will be compacted. Okay, so that is how it will maintain the earth surfaces later. Okay, then coming to this other types, what you have retaining walls here, it is shown. You can see the different types of retaining walls what you have. So one, what I told is the stone masonry retaining wall, what we saw in the first picture, that is a type of a gravity type of retaining wall. Okay, because it maintains its stability due to its own weight. That's why we call it as a gravity retaining wall. Okay, the masonry retaining wall, which was there in the first picture, what we saw, stone masonry retaining wall, it is a gravity type of retaining wall. Okay, the name comes because due to its own weight, it maintains its stability. Okay, like we have gravity dams. Okay, the same concept applies in case of this gravity retaining wall also. Okay, so that is what the gravity type of retaining wall is. A semi-gravity type wherein you also find some portion of it is being reinforced. Okay, and it acts as a barrier, and some part of it is maintaining the stability is maintained due to the self weight. Okay, there is a combination of reinforcement as well as uh, the gravity type of retaining wall. Okay, and coming to the next type, okay, we call it as a cantilever type of retaining wall. Okay, this you can clearly see the why it is called the cantilever type of retaining wall. This portion of retaining wall, which we call it as the stem, okay, this vertical wall, which is actually the retaining wall, we call it as a stem. This portion of the wall is called the stem. So this stem behaves as a cantilever. Okay, it is connected with this base slab. This entire slab, what you find here, it is a base slab. Again, in this you have toe portion and the heel portion here. Okay, and this together all we call it as a base slab. Okay, so this portion of the wall stem, it will project out as a cantilever beam. It will be projecting out in the form of a cantilever. So that's why this name, the cantilever retaining wall, is given to it. Okay, this is another type of retaining wall. We will be actually designing this type of retaining wall, cantilever type of retaining wall. Okay, now one more type, what we have is a counterfort type of retaining wall. In this picture, what you are seeing, this is a counterfort type of retaining wall. What difference you find is there will be intermediate supports. This is the stem or the vertical wall, what you find over here. This is the base slab. Okay. In addition to these, there will be walls which will be connecting this stem and the base slab on this side. Okay. You can see these discontinuous lines have been shown over here. They are called the counterforts, and they connect this stem with the base slab here. In turn, they change the behavior of this entire retaining wall. Earlier, what was happening was the retaining wall, it was behaving as a cantilever beam. Okay, so this wall, what happens is it will act as a cantilever beam over here. So the bending nature is just like our cantilever beam. So it will be bending something in this form, like a cantilever. Okay. Whereas in this case, this behavior will change completely. Okay. So that will be, we'll study in detail how that happens. Okay. Right. So what happens in this case is when I provide these intermediate counterforts, from cantilever nature, it becomes a continuous beam. The stem behaves as a continuous beam supported on these counterforts, or we can say as a continuous slab also. So it will act as a continuous slab, bending in the form of sagging and hogging, supported over these counterforts. Okay, so that nature has changed entirely. Okay, so when the height of the wall increases, this height, okay, this vertical height of the wall, when it is too large, it becomes very uneconomical and it will not be very much feasible to provide or design this as a cantilever retaining wall. So instead, what we do is we adopt such intermediate supports in the form of counterforts to change the behavior, and this particular type of retaining wall is much more economical compared with the cantilever type of retaining wall. Okay, so that is the purpose of providing these counterforts for the retaining wall. Okay, so another type is just opposite to this counterfort type of retaining wall. There's a buttresses type of retaining wall. Okay, the difference what you find is the soil which we are going to fill, or which we call it as a backfill. Okay, so here once I construct this retaining wall, I'll be filling the soil on one side of this retaining wall. Okay, so the side in which you fill this soil and compact it over there, we call it as a backfill or the back face of the retaining wall. So this is the side where soil has been filled. This is the backfill. This is the backfill over here. It may be horizontal, it may be sloping, depending on the necessity. So this is the backfill side. So here, counterforts, these walls which connect the stem with the base slab, if they are provided on the backfill side, we call them as a counterforts. In turn, if they are provided on the other side of the backfill, then they are called as a buttresses. The behavior will remain same. Okay, for this stem, the entire behavior will remain same. Only difference is these wall will experience tension when they are provided as a counterfort, and they will experience compression when they are provided as a buttresses. That is what the difference it is. Okay, the entire behavior will deal with it later, but these are similar type of walls, counterfort retaining wall and the buttresses type of retaining wall. Okay, when we actually design the counterfort, we will see how it is to be designed over there. The behavior, what you find, the stem behavior will remain same. There will not be any change in the behavior of this stem. It will act as a continuous slab supported over these buttresses or the counterforts. Okay, so that is what you find over there in counterfort and buttresses type of retaining wall. The position of these walls, the counterforts or buttresses, Okay, that's what it makes the difference. If it is a counterfort type of retaining wall, these are provided on the backfill side. These walls which connect stem and the base slab, they are on the backfill side. When we call it as a buttresses type of retaining wall, they are present on the front side of the retaining wall. Okay, they'll be connecting the stem and the base slab here. Okay, so that is what you find the difference over here. Now, coming to these parts or the components of the retaining wall. So what you find here is these are the components. So one component I told you, the stem. Okay, also the base slab. Now this base slab is divided in two parts. One is the toe portion, the other is the heel portion. The toe slab and the heel slab. Okay, so the portion of the base slab which is projecting beyond the stem, okay, and is on the front side is called the toe slab. Just like we have the toes in our legs in our foot. Okay, so the toes are on the front side. The toe slab is in the front side of the retaining wall, whereas heel slab is on the back side of the retaining wall. Back side means on the backfill side of the retaining wall. The portion of the slab, base slab, projecting towards the backfill side is called the heel slab. Projecting towards the front side of the stem is called the toe slab, toe and heel slab. Okay, so these are the three main components in a retaining wall: stem, toe, and heel. Okay, so these are the lengths what are indicated here. Okay, we'll be using some different abbreviations, but this is the length of the heel slab. Starting from where? Starting from the face of the stem, the front face of the stem, up to the end over here, up to this end. This will be our length of the heel slab. And starting from the face of the retaining wall, this projection is the length of our toe slab. Length of toe slab, length of heel slab, and height of the retaining wall. This H represents the height of the retaining wall. Just note it also includes thickness of this base slab, TB. This is the thickness of the base slab. So this total height includes what? Height of the stem plus the thickness of the base slab. This is the height of the retaining wall. So these are the components. Okay. Now, one more thing what you observe here is in some cases, or it is general practice that we reduce the thickness as we move towards the top of this retaining wall. Mainly in case of counterfort retaining wall. This is done. Why it is done here? Any answers for that? Yeah. Any answers for this such a section? You can see TS, thickness of stem at the base, okay, and at the top. If you compare, they are different. They are not meant as kept constant. So what is done is it is tapered and the thickness is reduced towards the top of the stem. Why it is necessary? Why that has to be done? Abhilash, you are there? Dodmani?
Yes, sir.
Any answer for that? Akash, anybody?
Sir, pressure is maximum at the bottom.
Okay. Then pressure is maximum. One reason is that. Okay. Due to that,
avoid overturning.
to avoid overturning, pressure is maximum, right?
Sliding.
Accepted. Then overturning, sliding, anything else? Kunal Rathod?
Sir, self balance of the wall.
Self balance of the wall.
Soil retention.
Soil retention. Omkar Jadhav. Hello, Omkar. Omkar Patil. Okay, one reason which is very much close. I think they are not there. Omkar and Omkar is very much acceptable. Is soil pressure is maximum at the bottom. Okay, that is one. This is shown over here. Okay, like that. But due to that, what happens over here? When I say cantilever, what is the nature of cantilever bending? What we have come across, what you have studied in a cantilever beam? When you recall your Benioff diagram, for a cantilever beam, what will be the typical points of a Benioff diagram? What you can say? What happens there is?
Maximum bending moment at supports.
Yes. So the maximum bending moment will be at the support. So where is the support in case of retaining wall? This base slab. Okay, this is acting as a support. Whereas this top of the stem is free. This is the free end of the cantilever. So here you will not find any bending moment coming across. So here you require minimum thickness. So normally that minimum thickness is 150 to 200 mm. That is what is maintained. 150 mm to 200 mm. So that we can accommodate the bars which are already provided and all. Okay. But the main reason is that we no longer require the larger thickness when we move towards the top. Okay, so that thickness can be reduced. Okay, so that is a purpose what you can have. Instead of providing a huge thickness throughout the entire height of the retaining wall, I can go for a reduced thickness at the top where I come across the zero bending moment or negligibly small bending moment over there. So that is the main reason what you have. Now, stability point of view, this retaining wall, that is the reinforced concrete retaining walls, they maintain stability in a different way. Okay, so weight components will be coming there. Okay, but I don't want to discuss that stability point over here. But this sloping portion is also used in case of the gravity type of retaining wall. In that case, the base is broadened, so that will help in maintaining the stability. Okay, in gravity type of retaining wall. Yeah, so when you move towards the base, a larger base is required over there. So, or that is helping us to maintain the stability. Okay, here also it is useful to some extent. Someone told about stability to avoid the overturning. So that is also helpful to some extent. Okay, but it depends on which side you taper that. Okay, so normally this tapering portion, I want to have it on the backfill side. On the front side, I want a perfect vertical wall. Okay, so this will be hidden inside the backfill. I don't want to have any tapering or slope portion on the front side. So normally that will be provided on the backfill side, and that also helps in maintaining stability, because this tapering portion weight, if you just calculate later, we'll see it will be very, very small. Okay, but it helps in maintaining that stability, maybe to a very small extent. Okay, so this is about different parts, okay, components of the retaining wall. Now these lengths, what I mentioned, length of the toe slab or the length of the heel slab, we need to decide them. Okay, we need to provide appropriate length of the toe and heel slab so that we avoid the overturning of this retaining wall. Okay, so that will be deciding over there. Also, this height of the retaining wall, that will be decided based on what difference in elevation is required between the two ground surfaces here. Okay, say I want to have this at some elevation. Say I want to have it 3 meters above. The difference in elevation between this surface and this surface, if it is 3 meters, say then my stem height will be this 3 meter plus whatever the foundation depth we provide over here. So that will tell us what will be the total height of our retaining wall. Okay, this total height of the retaining wall depends on what is the difference in elevation between the two ground surfaces and the depth of foundation. That will decide the height of retaining wall. Length of toe and heel slab are decided on the stability considerations. Okay, then coming to the forces to which the retaining wall is subjected. This is all about the components of the retaining wall. What I just discussed is about the components of the retaining wall. Okay, don't worry about this length of the toe and heel slab, how to calculate them. We'll do that later when we take up the problems, or before that I'll explain that. Okay, now let us see the forces to which we need to design the retaining wall. Okay, the very first force, the primary force for which we need to design the retaining wall is the lateral earth pressure. Okay, since I'm providing this retaining wall to hold this backfill, okay, and maintain the elevation difference between these ground surfaces, what I have is this backfill will try to exert pressure on this retaining wall. We call that as a earth pressure, and mainly the active earth pressure. Okay, so this is how the pressure distribution will be due to the lateral earth pressure. Okay, this is the lateral earth pressure distribution. It will be horizontal, acting towards the stem, normally on the stem. Okay, and varies in a linear manner. Zero at the top surface, okay, and maximum at the base of this retaining wall. It increases as you move downwards from the top surface towards the base of the retaining wall. So at the base, it is maximum. Now, how do we get this? This is calculated using a earth pressure coefficient. Ka is the active earth pressure coefficient, what I have written here. And this is gamma, the density of this backfill. What is the density of the backfill? H, the height of the retaining wall. So at the base of the retaining wall, the maximum earth pressure, okay, Pa, active earth pressure, will be Ka gamma into H, just like our hydrostatic pressure. I hope you have studied this already in your geotechnique. Okay, so this is the soil pressure distribution on the retaining wall. Okay, varying in a linear form. Zero at the top, maximum at the base of the retaining wall. And what is the maximum value of the earth pressure? K gamma into H, active earth pressure coefficient, into density of the backfill, into the height of the retaining wall. Okay. Now, the resultant of this entire earth pressure, if you are to find it, you have to find the area of this triangle. Okay, this UVL, uniformly varying load. What is the area of this? If you find it, that itself gives you the resultant earth pressure. Okay, which will be half into this Ka into gamma into H. Okay, so actually it will be H square, base of this triangle. That has not come here. It should be H square, half Ka gamma H square. The square is missing. So this is the resultant earth pressure here. Now position of this resultant will be at the centroid of this triangle, which is at a distance H by 3 from the base. Okay, centroid of this triangle, H by 3 from the base. So that is the location of our resultant. This is one of the force, which is a primary force in our earth retaining structure. We are designing this retaining wall to sustain this force. The first main force is this. The stem has to sustain this force. It has to withstand this force. If it has to maintain this backfill in a proper position, then it should be able to withstand this force. Okay, so this is the lateral earth pressure, what you have, for which the stem will be designed over here. Okay, now this is the magnitude of earth pressure, resultant magnitude of the resultant earth pressure, position H by 3. Okay, now this is what our active and passive earth pressure coefficients are. Somewhere in later part we'll come across this passive earth pressure coefficient also, but this is how we calculate them. Active earth pressure is given by 1 minus sine phi by 1 plus sine phi, and passive earth pressure will be 1 upon K, okay, or 1 plus sine phi by 1 minus sine phi. Phi is the angle of internal friction for that particular soil. For the backfill, whatever the internal friction you have, coefficient, angle of internal friction, so that will be the phi value. Okay, so this will be the forces. These are the forces what you have. Please make sure that these things are clear. If any doubt is there in that part, you can Ask me. So we have seen what is the purpose of having the retaining wall? What is actually a retaining wall? Different types, different parts in a retaining wall. Okay. Any difficulty or doubt in this part? Because you should be knowing what is retaining wall, what is the purpose, then you can design it properly. And also types, different types of retaining wall will be designed differently. Their behavior will change. In gravity, the weight of the retaining wall is important factor. Okay, it maintains its stability due to that weight itself. The overturning of this entire wall is prevented due to the self weight of that retaining wall. Reinforced concrete retaining wall, they are designed for the internal stresses. The bending moment, shear force have to be taken care in case of reinforced concrete retaining wall. Okay, so I told counterfort, this is just a counterfort retaining wall. Okay, just similar. I don't know well later construction part how it was, but this is how a counterfort retaining wall actually looks. So you can imagine that this is a slab. Okay, this vertical wall, what you find here, slab supported over a continuous beams. A continuous slab supported over the beams. These counterforts will act as a beams. They are acting as support to this slab. So it is continuously supported over these beams, just like our roof slab. It will behave as a continuous slab in this case. Whereas here, this is a cantilever type of retaining wall, what you see here. Okay, so it will bend like a cantilever. Here you don't find a toe slab. Okay, this is a L type of retaining wall. L type of retaining wall. Base slab is not having any toe slab here. Toe slab is missing. I may avoid providing the toe slab. Design will change, but sometimes it requires you to prevent providing toe slab. Your boundary may be here itself. You have to stop your retaining wall here. You cannot make encroachment in next area. So there, toe slab have to be avoided. Situations may arise. So here, toe slab is prevented. Okay. So if you can also see closely, right, there are some holes provided here. Okay. Is it visible for you? What I'm showing over there? Are these holes clearly visible to you?
Yes, sir.
sir.
Okay, so these are called, any guess?
V poles.
Yeah, P poles. What will they do?
Remove the water.
Remove the
Water.
water. Okay, they are meant for drainage purposes. Okay, remove the water. See, in the beginning I told these are earth retaining structure. They are not liquid retaining structure. So it is important that you drain off the water as quickly as possible. One is it will increase your density of the soil. It gets saturated, okay, or it may be unsaturated, may not be fully saturated, but whatever it is, when water comes inside this backfill, it will increase the density over there. But what is the this one force to which this retaining wall is designed? It is designed for the lateral earth pressure. Okay, so in considering that density of the backfill, it may be taken as a partially saturated soil. Okay, so there the density will be increased, but you should take care that it doesn't become fully saturated at any point. Okay, I cannot design it for a huge saturation which may not occur at all. So these holes normally they help in draining off this water which will be entering inside the backfill. Definitely there will be when it will be raining, you will come across the water coming inside your backfill. You cannot say that I cannot have totally, you cannot provide any waterproofing, anything in such structures. They are exposed to rain, they are exposed to water, there will be runoff over these surfaces, everything will be there. So proper provision have to be made to drainage, to remove that water from the backfill. It will enter inside the backfill. but we need to remove it properly immediately outside. If you have problems with your slabs leakage or any part which will be leaking, in case of RCC, the first remedy is remove that water. Provide provisions, sufficient drainage provisions. Better than waterproofing is provide sufficient drainage provisions. Don't allow the water to stand there in a stagnant position. That will create problem. That will corrode your reinforcement. That will deteriorate your concrete. That will pose a lot of problems. So immediately remove that water. That is the best solution. Then in case if it is not possible, later other things are there. So see that will be there. Now coming to the forces again, if you don't have any problem with these concepts of retaining wall, now coming to the further part of these forces in the retaining wall. So one is this lateral earth pressure to which the stem has to be designed. In addition, what you find is the weight components will come here. Okay, so you have the weight of the backfill which will be acting on this heel slab in a downward direction, vertically downward direction. What is the weight of backfill? Density of backfill into the height. We'll be taking 1 meter length of this retaining wall. We'll design the retaining wall for 1 meter length like we do for slabs. We'll consider 1 meter length of the retaining wall. Then for that, we'll design the same reinforcement, the same section will be provided for the entire retaining wall. It may run for 2 meters, 10 meters, 20 meters. The same thing will be maintained over there. So when I take that 1 meter, if I want to calculate the weight of this backfill over the heel slab, okay, so it will be simply density of the backfill into the height. Okay, so this thickness of the base slab, it can you have to deduct it. Okay, we'll be considering the weight of the base slab separately. So this weight of backfill will be equal to density of backfill into the height of the stem. Okay, up to the top of this base slab. So this is another force. It will be acting vertically in a vertically downward direction. Okay, now in addition to this, at the base, okay, at the bottom of this base slab, what you have is the soil pressure. The vertical soil pressure will be present over there. Okay, so that will be acting in this form. It will be acting in a vertically upward direction. So on one side it will be maximum, and on the other side it will be minimum. On calculation, we'll come to know where the maximum, it is maximum, where it is minimum. Okay, so this length of the toe slab and the length of the heel slab will all affect this pressure distribution at the base of this base slab, at the bottom of this base slab. Okay, so these variations, Q max, Q minimum, it all be affected from this length of the toe slab, projection of toe slab and the heel slab, Q max and Q minimum. Variation will be like this in this form. Now, what you need to ensure is this should not exceed the safe bearing capacity of the soil. In any case, if it is exceeding the safe bearing capacity of the soil, then the soil will fail over there. Okay, so that will be a problem for us. So that will result in failure of the soil, and eventually it will the retaining wall will fail. And over this, at this point where you come across the minimum upward soil pressure, you should make sure that it is not negative. This portion of the base slab will not lift up. If it is coming out to be negative, indicates it is transferring tension to the soil, which is not possible. You cannot transfer the tension into the soil from this base slab. So if it is coming out to be negative, it is indication that the base slab is lifting up from the soil. It is losing contact with the soil. What happens when it loses contact with the soil? My width of the base slab will now get reduced, or the area over which this entire soil pressure or this weight is being transferred will get reduced. Again, that will reduce the area of our footing. It is just like reduction in the area of the footing. So that will increase the soil pressure in this remaining portion, which will lead to the failure of the soil. So increased soil pressure, if it is in excess of the SPC, that will cause the failure of your soil. Okay, so it may be soil failure. Any type of failure may occur over there in the soil. So you need to check this upward soil pressure against SBC and this minimum soil pressure, upward soil pressure should not be negative. That has to be ensured over there. Okay, so that will be the other force which will be there. In addition, the weight of the stem slab will be considered while calculating this upward soil pressure, and also weight of the base slab will be considered. Knowing the dimension of the stem slab and base slab, we'll come to know what is this W1 and W2, which are the weight of stem and base slab respectively. So they will be acting in vertically downward direction. Both these W1 as well as W2 will be acting in vertical downward direction. Okay, so that will be the direction how the two all these weights or the forces will be acting in case of a retaining wall. So these are the forces to which our retaining wall will be subjected. Okay, so when you have a road or a road being constructed, or what we do is we have the depth of foundation here. Okay, over here the depth of foundation is there, so there will be filling, some filling will come on the front side of this retaining wall also. So there will be some earth pressure which will be coming from the front side also. This will also provide some earth pressure on the front side of retaining wall. I'm not shown that over here. Okay, that will be very small one. The depth of the soil which is being filled on the front side of this retaining wall will be very small compared to this backfill. Okay, that, and one more is during early construction stage you don't have this filling provided over here. Okay, that is a worst case. Okay, so what that will try to do, that will try to increase the stability. This pressure due to this filling on the over the toe slab will try to increase the stability of this retaining wall. So we need to check the retaining wall for the worst possible condition. Okay, worst possible condition is in the early stages of construction. Here, see, no filling is done here. Okay, later the filling may come, some filling may come in this portion here. Okay, so at this point, they will start filling the earth on the back side of the retaining wall. This backfill will be filled and it will be compacted first. Later, the front side on constructing the road. So this will be normally neglected when we are studying the forces acting on the retaining wall. Okay, it may come late in a later stage, but normally when we are designing, that part will be neglected over there. Okay, so these are the forces what we have over the retaining wall. Vertically downward forces due to the weight components of backfill and the retaining wall itself. Okay, and lateral earth pressure due to the backfill present over here, which is a horizontal force. And since this entire retaining wall rests on a ground, okay, so it will be also having a soil pressure, okay, as a form of this one, like this soil pressure distribution beneath it. Okay, so these are the forces. Okay, stability. Now this picture is showing you the stability failure of the retaining wall. How it will fail due to instability. Okay, one is overturning. See, I have not told you any part of the retaining wall is failing over here. The entire retaining wall is safe. There will not be a failure of any part, the toe slab or the heel slab or the stem. They are not failing. They are safe. The RCC design is safe. Okay, what is happening? The retaining wall as a whole, it is overturning. Okay, if you don't underestimate that this one dimensions of the retaining wall, this is what is going to happen. Okay, the base slab dimensions, if they are underestimated, they may be safe, but overturning will occur. So it is trying to rotate over here. Okay, this is overturning, one instability. Another is sliding. Okay, so what happens is this sliding is prevented due to the friction between this base slab, and the soil beneath the base slab. So there will be a friction between this concrete surface and the soil. Okay, so what is the frictional force acting over here? It depends on the coefficient of friction, what exists between the base slab and the soil over here. So this is the friction what will be coming over here. So this will try to prevent the sliding of this retaining wall. Now if this horizontal force, what you have here, this horizontal force is nothing but your the active earth pressure, PA, which we had calculated. So if PA, if it is excess of this frictional force, what you have at the base, then it will slide. So we need to check it. We need to check and ensure that this sliding won't happen. Okay. And another is bearing. So I told you the Q max value pressure. So it should be less, or else what will happen is this soil will get crushed, okay, or it will fail. Shear failure, general shear failure, anything, other type of failure will occur over here. Local shear or such failure will may take place. So it will fail. The soil has failed over here due to bearing. Okay, Q max is more than the SBC. That is what has happened in this case. So if we have the Q max, when it exceeds the safe bearing capacity of the soil, this will happen. Okay, so these are the stability considerations. Before we go for designing the retaining wall, you have to check these stability points. Okay, fine. So these are for your concrete part. So these are some good books what you can refer. Okay, Yan Krishna Raju, R.N. Pranesh, Reinforced Concrete Design. Okay, and one more is Sinha, Pillai, Unni Krishnan Pillai, and Punimiya and Subramanya. These are some books what you can have as a reference. Okay, this is the behavior types and all what we have seen. Now, to keeping these things in mind, in the next class we'll go ahead with the design of retaining wall. And before you leave, wait, don't exit the meeting. What you have to do is type your name, USN, and division in the chat box. That will be your attendance. So attendance will be is being considered. It is being monitored. What you have to do is you have to put your name, okay, USN, and division all together. Don't put them separately. All together, you have to put it in the chat box. Abhilash Dodmani didn't said what is the Sushma. Okay. Anybody wanted to ask anything? I have not seen the chat box. Huh? Some of you have put something over there. Pawan Lote, put it with everyone. Chat with everyone, not individually. Put it in the general, this one. Okay, that will be your attendance. Once you put your name, USI, and division, you can exit the meeting. I have scheduled this. This will end at 12:30. So before 12:30, put your USN name and division. Who is this BD? Basama Katti, Girish Ambigere, Praveen Kumar, M. Praveen Kumar, Namrata Kulkarni, Nikita SY, Purvi G, Vijay Lakshmi Shinde, Jawahar MK, absent. Even if you are in the meeting, you are not there. BD, who is BD?